Today we have come to present our topic on water, and it's going to be Latif. During our lecture on environmental pollution, we posited that air and water are two major substances in our environment that are most important, simply because of the life supporting functions that they carry out. And again, apart from the life supporting functions that they carry out industrially, they are still very useful. Even domestically, they are very useful. Like we use water for cooking, for bathing, or for washing our clothes. Air is used in the industry for many things. Either for filling of balloons, for some experiments in the laboratories. And we also went ahead to discuss what could make them to be impure, and we also emphasized the need for separation in case there is presence of impurities in these all important substances. That is the summary of what we did on environmental pollution. So we went ahead to discuss air as a main topic. So now we are going to discuss water, that is the counterpart of air, because of its importance that we have highlighted before. So it is our aim that after this class, the whole concept of hardness of water, all the advantages, the effect of hardness of water, and what are the causes, be understood by students. As a matter of introduction, we said water is the commonest compound on this planet. Yes, simply because of its all-encompassing presence. It's all-inclusive in many substances and even in organs of the body, like bones, like kidneys, like blood. All of these contain water. In fact, our almost 85% of the body of human beings and other animals contain water. And again, more than 70% of the Earth's surface is covered with seas and rivers. You can now see that the importance of water cannot be overemphasized. That is why we are giving it adequate treatment, so as to be able to understand how important this substance is. And apart from these life sustaining properties of water, life sustaining functions, it is also used in our homes and houses for cooking, for drinking, and for cleaning all sorts of things, easy for bathing or for cleaning our materials. And again, the industry, as a chemist, we have to talk about industries. That is why. So it is used as a solvent in industry, because water is a universal solvent. That is, it can dissolve many substances. It is used as a coolant, that is in heat exchangers, when like carburetor, like evaporator, like condenser, like air conditioner. Water is used as coolant. Also, like we use it for cleaning at home. It is also being used for cleaning in the industry because it can dissolve many things, so it can be used for cleaning in case there is recalcitrant or there is stain on any of our substances. Then again, it is used as a chemical reactant. It is simply because of its solubility, or many substances soluble in heat. So we can see that these uses of water cannot be emphasized. It is very useful. In fact, hardly it is impossible that either in our homes or industry that we cannot get in contact with water each day. It is not possible. So the subject of water is not something that should be taken with levity hands. Water is a neutral substance that is colorless, odorless, and tasteless. Anything that makes water to be colored is an impurity. Anything that makes water to be tasteful is also an impurity. At STP, or let me say at atmospheric pressure, pure water boils at 100 degrees centigrade and freezes at 0 degrees centigrade. We talk about what impurities are when we're talking about separation of mixtures. We said sometimes impurities might not be the bad thing, but if water is required in 100% purity, anything, no matter how good it is, that is present in the water, it's an impurity. The color of copper solvate, that is always white, so when it comes into contact with water, it suddenly changes to blue. This is a very good test for the presence of water in a substance. So if you want to know if a particular compound contains water or if a substance is water, maybe a colorless liquid, just a matter of getting copper sulfate. It is what? It is white already. It is a salt. So when we add that substance to it, anything that makes it change to blue, that means the substance is either water or it contains water. Also, we have cobalt chloride paper. It is blue. When it got into contact with water or a water containing substance, it changes to pink. This is another confirmatory test for the presence of water. So those are the properties of water, general properties of water. To be specific, unique properties, because apart from all these general properties, there are some abnormal behaviors of water that ordinarily we don't expect water to possess such kind of properties. Number one is usually high boiling point. What we understand is that when we have molecules, the boiling point of those molecules is proportional to the size of the molecules. In other words, the boiling point is proportional to the molecular mass. So when we have a very high molecular mass, we expect very high boiling point. When we have very low molecular weight, we expect a very low boiling point. But despite the fact that water has a very low molecular weight, 18 grams in 1 mole, its boiling point is as high as 100. So that is unusual, that is abnormal. It's part of the unique properties of water. In fact, it enables it to be useful for many industrial applications because of that high boiling point. Again, it has a greater specific heat capacity than almost any other liquid. Its capacity is the amount of heat required to raise the temperature of a unit mass of substance by 1 degree Celsius or 1 Kelvin. So water has a very high specific heat capacity, like 4,200 joule per kilogram per Kelvin. It is very high for the size of water. Another anomalous behavior of water is the density decrease when it freezes. That is why we see icebergs that floats on water. It is simply because as water freezes, the density reduces. It is abnormal because we expect that when something solidifies, we expect the density of it increased, not the other way around. But as we found it, water is opposite. So that is one of the unique properties of water. All these unique properties, they have they make water to be universally useful for everything that is being used for. So that is on the properties of water, whether it is unique or the general properties. So now let us go into what is called hardness of water. In our homes and industry, it is very rare, or let me say impossible, that our water that is being exposed to another substance, maybe it is the atmosphere or even in the container with it is packed, to not contain some other things inside. What I am trying to say is this: it is close to impossible that we have our water to be 100% pure. This is simply because if the water is exposed to the atmosphere, there would be some dissolved gases. If it is packed, it is put into some containers, there could be some dissolved solid inside. So all this dissolved material, they are not particularly harmful. Sometimes they are good, but not every time. So where do these solids come from, or these liquids, these gases? When we have rainwater, we have carbon dioxide in the atmosphere. It is very soluble in water. So when it comes into contact with water, there's going to be a chemical reaction. Although it is not completely soluble, because CO2 is sparingly soluble in water. So when CO2 now comes into contact with water, there's going to be a chemical reaction with water and they form a weak acid, H2CO3. This is the chemical equation. This is the water from the rain. This is the CO2 from the atmosphere. They now get into contact with each other. There's going to be formation of this weak acid, carbonic acid, or better still, we call it trihydrocarbonate 4 acid. This particular acid now, it flows on the ground. So when it flows on the ground, there are some dissolved salt in the ground also, or sometimes it flows on the rock surface. So when it got into contact with some other salt, whether in the rock or in the soil, like limestone, like dolomite, like stearate. These substances are attacked. Acid rain can dissolve many things. This is acid rain because it's acid. It can dissolve many like-minded salts. So if it got into contact with this calcium carbonate now, or let's say magnesium carbonate, there's going to be dissolution reaction. Then when it dissolves, there's going to be formation of calcium hydrogencarbonate. This is and it's a soluble, that is colorless substance. We won't even know something like that has happened, because this compound is a very colorless compound. It is transparent. The same thing if magnesium carbonate is the one that got into contact with H2CO3, there's going to be formation of magnesium hydrogencarbonate. Again, another colorless salt, another colorless substance. Some of the rock, because in the rock there are many dissolved salt there. It can be calcium sulfate, can be the anhydrous of that calcium sulfate, can be stearate, as I've said earlier. These are very super insoluble in water. So the presence of each of these material in that water, whether it is hydrogen carbonate, whether it is solvate, whether it is chloride, it makes the water to be hard. That is what is called hardness. That is the chemistry behind hardness. Then what is now called hard water? Hard water is just type of water that doesn't lather really with soap. Maybe some of us will have experienced it when we are washing. It's not every time that small amount of either soap or detergent is used. This is as a result of containing some salt. If you have the opportunity to bath with water that contains salt inside, you will see that you waste your soap or your detergent if you are washing clothes, simply because it contains some dissolved salt which will attack the soap and form another substance that is called the scum. We are getting to it now very soon. It is called the scum, and that scum will prevent the soap and the water from forming lather. That's what is called hardness. So there are two types of hardness. Number one is the temporary hardness, and the other one is the permanent hardness. So temporary hardness is caused by calcium or magnesium hydrogencarbonate. The example we first did. So when we have calcium hydrogen triosocarbonate, then we have what is called temporary hardness. Why it is being called temporary? It is because it is easily removed. Just by boiling, we can remove that hardness by boiling, because this substance that we said, this hydrogen carbonate of calcium or magnesium, when it is heated, this hydrogen will go away to form calcium carbonate. This calcium carbonate, instead of to form this in a reverse reaction to form this, it won't form this carbonic acid. It's going to form water and CO2. So when calcium carbonate is now formed inside that water, then it is going to be a precipitate. It will not attack this detergent again. Then when we have the water and CO2 that is split, then it is not going to attack other calcium carbonate in the water. So the water is readily available to form lather just by boiling. Permanent hardness. This is again due to the presence of dissolved salt. But which of the salt now? It is not hydrogencarbonate this time around. It is the sulfates of calcium or magnesium. So permanent hardness is much more difficult to remove, simply because it doesn't have anything that will decompose on heating. Like sulfate is very stable. Any sulfate of magnesium, any sulfate, whether it is calcium or magnesium, it is very stable to heat. So simple boiling cannot remove this type of hardness. That is what is being called permanent hardness. So when water containing any of these substances is evaporated, a white solid deposit of calcium or magnesium sulfate and or calcium carbonate is left behind. That is the principle behind heating here. So when it is being heated, there's going to be formation of calcium carbonate. That calcium carbonate is white in color. It is just going to deposit itself at the bottom of the kettle or the boiler. That boiler said it contains solid deposit of water that is called fury. So that is for temporary hardness. For permanent hardness is going to be calcium sulfate or magnesium sulfate. It's also white in color. So when water containing any of these substances now is heated or less evaporated, that is heating to dryness, there's going to be deposit of all this, and this is as a result of hardness of water. So let us appreciate what we are trying to say by these diagrams. This is from our labs. This is a test tube that contains normal water. This a test tube that contains dissolved substances that is present in water. This is not normal water again. So when this normal water is evaporated from this, then there's nothing left. The test tube is as clean as it used to be. But in these two cases, this is temporary, this is permanent. So when the water is evaporated, there is formation of whitish substances around the wall of the test tube. This is also due to the formation of the calcium or magnesium sulfate. You can see it is white. It is very plenty here, simply because this hardness, this permanent hardness. Again, in this place, this is our boiler. We see some whitish substances around the rings of the boiler, because the boiler is being used over and over again. So it makes those decomposed salts, calcium carbonate, to be deposited over time. I've seen this very thick here. Then other places that are not thick, because there's elements of some calcium carbonate around the rings. This is called furring kettle. When it is furring, it causes furring of kettle, simply because of the deposit as a result of overuse of all this, with exposure of this with hard water. Again, this is a pipe that used to contain hot water, maybe in the heat exchanger. We have seen, this is thick lime scale. You can see this is the tube itself, the inside here that water used to pass. This is hot water. As a result of deposit of this salt, we see this thick. It is as thick as anything. That is as a result of hardness of water. in the pipe. Again, this is stalactite and stalagmite. Stalactite is the growth, like ice cycle, from the top of a rock that contains calcium or magnesium hydrogencarbonate. So when there is heat, intense heat in the rock, there's going to be decomposition of this calcium or magnesium carbonate. So this will now come down. This something like something is dropping. Over time, there's going to be solidification of this, and it's going to be from the roof of that cave. Now that is called stalactite. The other one that grows from the floor, so a sort of droppings from the hop here. Something is dropping, then it grows over time. That is called stalagmite. This is the stalagmite. And the other one that is coming from the top is called stalactite. It's a sort of decomposition of this sort. So what are the effects of hard water? The general thing is that it is difficult to form lather. So it wastes water as a result of the presence of that solid material, that is a precipitate, form a reaction with the dissolved substances and water, and soap. So when we have dissolved substances in water and soap, then there's going to be a chemical reaction. This is from the soap material. This is from the hard water, temporary hardness. So when we now have, maybe we use water for bathing or for washing our clothes, there's going to be a chemical reaction here. Then when we have something like this, we're going to go form calcium stearate. This calcium stearate is called scum. This scum is a precipitate that prevents water from forming lather. This lather. So we need much soap in order to wash little substance, little material, simply because of this formation of heavy scum. Sometimes they make water to be colored, as we have seen in that test tube. Presence of salt in water makes the color of the salt to be pronounced in water if there are plenty inside that water. They cause the water to be tasty because ordinary salts are tasteful. So when there are now plenty in water, then the taste of the water is manifested. About the weight of the salt, the weight of the salt is manifested inside that water. Then this is a problem. Then how do we cater for it? How do we prevent it? Or when it happens, how do we treat short water? Because economically it is not sustainable, it is not reasonable to leave hard water like that for economic reasons, whether it is industry or it is in our homes, because it causes waste material. So number one is the temporary hardness that is removed by boiling. As I've said earlier, when the water that contains this is heated, there's going to be decomposition of this, because this is not stable. There's going to be decomposition of this. When it decomposes, then water and CO2 goes away. These are water, and then this calcium carbonate that forms as a precipitate down the kettle or the boiler or anything. So this is what caused fury that we saw the other time. So by this, there's no carbonic acid that is going to react with this again to form hydrogen carbonate. So invariably, we have overcome the formation of calcium carbonate by preventing prior formation of this hydrogen carbonate. I'm just using calcium because it is very common. Magnesium can also be used. An example, it's going to be the same thing. Instead of magnesium carbonate, it's going to be calcium. Instead of calcium carbonate, it's going to be magnesium carbonate. This is a simple way of removing temporary hardness. So for permanent hardness, it cannot be removed by boiling, simply because there's nothing that will decompose in this permanent hardness. So now there are other ways of doing that. Number one is addition of washing soda. When we have washing soda, then there's going to be chemical reaction with the washing soda and the ions of the hard water. Then it forms this. Our aim is just is formation of carbonate, whether it is calcium or magnesium. So this CO3 minus this carbonate radical is from this washing soda. This Ca2 plus is from the hard water. So when there is chemical reaction between the two of them, there's going to be formation of calcium carbonate, which is a precipitate. Then water is free of hardness. Another method is ion exchange. This is a very good method when we have a resin that is packed in a column. A resin, sometimes resin clay can contain sodium. In fact, sodium is the main ion present in the resin. So when we have a packed column of resin, we can pass our hard water into it. When hard water is passed into it, there is going to be exchange of ions. Calcium will be exchanged with sodium here. Then we have got to form calcium resin, then sodium that is harmless. It's going to be inside. So by this we have removed, because this one is we now form sodium carbonate that is soluble in water and does not prevent water from forming lather or from it doesn't form hardness. This can be regenerated by passing it over sodium salt again for reuse, because there may be a case when it will be reused over and over again. Another one is distillation, as we have said when we are treating separation of mixtures, that if we want to get solvent from the solution, distillation is used. So when we have water that contains some element of the salt that is responsible for hardness, we can use distillation. Distillation will leave the salt behind while water is being distilled over. Though the problem or the drawback of this method is the cost. It is too expensive. It cannot be practiced on a very large scale, as the industry or the organization will run into loss. We have said earlier that hard water is not that disadvantageous. There are some advantages of hard water. It now depends on if we need those advantages. Number one is the nice taste, because the taste of salt is nice. So water that contains salt is very nice in taste. Then again, calcium ions in hard water are required by the body for bone formation and teeth, because even magnesium is used by the body for gum formation. So when water contains either calcium or magnesium, it is still useful for body and body requirements. Then again, instead of water to dissolve, ordinary water, clean water, to dissolve lead that is being used for coating inside our water carrying pipe. A hard water will dissolve the lead and form lead sulfate or lead carbonate. Ordinarily, if you have clean water that is passed into such a pipe, it dissolves the lead, then the lead will be carried away inside that water. When human being now taste or drink that water, they inject what is called lead, and that can cause lead poisoning when a preponderance or a substantial amount of lead is being injected into the body system. There's going to be formation, there's going to be something like what is called lead poisoning. But hard water, when it's passed into the pipe, because it contains some carbonate or sulfate, ordinarily water will remove the lead in the coating. Then instead of the lead to be carried into the water, it's going to react with the solvent and form lead sulfate, which is harmless to the body. So it has cut down the possibility of what is called lead poisoning. And again, industrially, some industries use hard water. Disadvantages are: number one, it's waste soap, that is economically is not good, causes get used to fall. That theory is what we saw in the boiler before. It causes hot water pipes to boil. We have seen it before in the diagrams that we presented. Then it can spoil the finish of some fabric because of the presence of the salt. So this is all what we need to know today in hardness, the subject of hardness, the study of hardness of water. But before we go, let us take a quick review of what we have learned. Water is used, apart from body requirements, as solvent in the industries, as coolant in a chemical reaction, as a reactant. There are many usefulness of water in industry, and again, homes it's used for cleaning, for drinking, for bathing, for many things. Hardness of water is caused by dissolved sulfates of calcium or magnesium, or hydrogencarbonate of calcium or magnesium. Temporary hardness is removed by boiling, while permanent hardness is not removed. It cannot be removed by boiling. Rather, it is removed by ion exchange, distillation, or addition of forcing soda. Hard water also has some advantages, because it's not every time that hard water is disadvantageous. So let us now solve some problem to demonstrate or to test our knowledge or understanding of what we have learned so far. Number one, steam changes the color of anhydrous copper 2 chloride from what? What is the color of the anhydrous copper 2 chloride? We say it is pink. So when there is steam, that is water, in very high temperature, now present, it is going to be changed to pink. Option D is the answer. That is for the test of presence of water that we discussed before. The fury of kettles is caused by presence of dust. Fury of kettle, that is temporary hardness of water, that is 2002 to 10 type K. Calcium tricarbonate, no. Does it cause fury of kettle? No. Calcium sulfate 6, calcium hydroxide, then this is the answer, calcium hydroxide. This, the presence of this one that culminated into this. This is the 4 on the kettle, but what caused the 4 is this one, that is option D. This question needs to be properly treated. Look into it very well and think about it. This is the 4 that's present in the kettles, that is that whitish substance. But the problem, the question now is, what is causing it? The cause is calcium magnesium tricarbonate 4. That's option B. Water boilers are used for long period of time. When they are used for that, the solid substance left behind as scale are dash. Magnesium trisilicate 4 and rust. Magnesium tricarbonate 4 and calcium trisulfate 6. Clay and magnesium trisilicate 4, clay and rust. Here we have not talked about silicate, but it is sometimes we have silicate in the water simply because of the silicon from the soil. Sometimes we have the silicate. Then again, in the glasses we have silicate inside. So maybe that can be responsible for formation of silicates in the water. So when we now have such water use, when boiled in boilers for a very long period of time, we are going to have what is called scale. That scale is the theory of boiler we talk about. That is option B, rather not option A. This is option B. Magnesium trisilicate 4 and calcium tetrasulfate 6. It's not rust. So this is what we have for today. I believe we all understood what we have presented. If that is the case, don't forget to like our video, and we're going to meet next time when we're going to present another topic on treatment of water for township supply and some properties of some sorts that has to do with presence of water inside. So next lecture is going to be the end of the section on water. So keep on watching our videos. Don't forget to share it and like it. Thanks for listening. God bless you.